Good day, ladies and gentlemen. I am the great detective Shark Lord Holmes, a secret agent working for the National Team of Folklore Investigation, also known as the NTFI. Recently, an interesting case came up, and I can't wait to share it with all of you. It all started when I received this letter stating that a fossil bomb was discovered in Gunshuiping, Taiwan, which will read some of the citizens there. This picture of the bomb looked an awful lot like a mud volcano, but they called it a fossil bomb because in their minds, when you put fossils in this nature's hot pot, it explodes. To see if that were true, I conducted some background research and, with the help of the Bakerham Street irregulars, went to the crime scene and the surrounding areas to collect evidence. In this presentation, we will first provide some background information on mud volcanoes. Then we will show you the information about the Gunshuiping mud volcano located in southwestern Taiwan, which we gathered using the electric resistivity method. Other evidence include the sedimentary facies of surrounding locations such as Yinfang and Danei, which can tell us about the geological history of southwestern Taiwan. Putting all of the clues together, we can figure out who or what is responsible for the mud volcano. Before going to the crime scene, I did a mini investigation on the mud volcanoes in Taiwan, including their properties and distribution. Mud volcanoes are volcano lookalikes, but instead of lava, mud flows out. There are some essential elements to the formation of mud volcanoes. First is the slurry, which is what the mud volcanoes eject. The slurry is a mixture of mudstones and groundwater. Next, the pressure underground needs to be high, which is usually due to the large amount of natural gas stored in depth. Finally, there needs to be a channel, a crack in the earth, to allow the slurry, along with the gas, to come out to the surface. These channels are mostly caused by tectonic stress. We look for evidence of the existence of these elements to figure out why there is a mud volcano in Gunshuiping. All of the identified mud volcanoes in Taiwan are found in the southern half, with most of them in southwestern Taiwan. The volcanoes in the west can be divided into several groups based on their geographic locations, near an anticline, near a fault, or on a plain. The mud volcano in Gunshuiping is on the Gaoping Plain, which is where the fossil bomb was reported. To understand why the mud volcanoes are distributed like that, we need to learn more about the geological conditions of southwestern Taiwan and find out what makes the place so special. So, the Bakerham Street irregulars and I traveled to the crime scene to continue with our investigation.
When we rushed to Gunshuiping, we saw not only one mud volcano, but four, not counting the one reported by the worried citizen. The other ones are dead or inactive then, even though one of them was witnessed by local residents to be still active half a year ago. To understand the underground structure of mud volcano in Gunshuiping, we measured the ground electrical resistivity in adjacent areas. This figure shows the bird's eye view of the mud volcano group. Green triangles represent the inactive eruptive vent of mud volcanoes, and a black triangle represents the active eruptive vent. We chose two survey lines, A prime and B prime, to measure the resistivity of the ground. Both of these survey lines are oriented in the west-northwest to east-southeast direction, with survey line 1, A prime, to the north of survey line 2. All eruptive vents of mud volcanoes are located between the two survey lines. We nailed the electrodes equidistantly along the survey line and set up the Wenner array, which is a method of measuring near-surface resistivity. We provide a specific current and measure the voltage between the two electrodes. With Ohm's law, We can calculate the near-surface resistivity and try to distinguish the composition of matter. This figure shows the result of our measurements. The different colors in the picture represent a different resistivity, and the unit is ohms times meter. Groundwater has good electric conductivity, and its resistivity is usually lower than that of rocks. We also found that the resistivity of mudstone is greater than 6 ohms times meter. Therefore, we can distinguish liquid mud, which is colored blue, from mudstone, which is colored green in the picture. We can find that there is large amount of liquid mud near the surface of the two sublines. We call it the mud chamber, and it is in direct contact with eruptive vent of mud volcanoes. Deep on the left side of subline 2, we can find an area with extremely low resistivity. We thought of it as a mud channel that allows mud to rise from deep underground to the mud chamber. Therefore, liquid slurry, solid mudstone, and mud channels are all found under the Gunshuiping mud volcano.
Hi, I'm the member of Bakerham Street Irregulars. According to the geologic map, the mud volcano in Gunshuiping sits on the alluvium, which covers a thick layer of mudstone which was found in Pleistocene epoch. In order to collect evidence and to see if the mud volcano has anything to do with the mudstone layers and the fossils, Holmes dispatched us to the bank of Tseng River, where many outcrops of sedimentary rocks were formed in the Pleistocene epoch can be found. The first site is Yujing. As you can see on the photo, the outcrop were mainly composed of homogeneous shells, where fossils of crabs and sea urchins were found. At the same time, there's a layer of tempestite, where a giant amount of shell fossils were found on the ground. Fossils in Yujing are mainly marine deposits, such as murex, crabs, sea urchins, and snapper's teeth. When there's a layer of tempestite, it means that this place might used to be under the depth that the waves can affect. With the fact of lithofaces, facies, marine deposits, and the tempestite, would determine that the ancient environment of Yujing to be offshore or even deeper. Also, when we were investigating Yujing, we noticed that there were big rocks scattered all over the bank. Using the magnifiers and the hydrochloric acid, we identified them to be limestone, which might be remnants of ancient giant coral reefs, because the rocks distribute randomly upon the shell. We inferred that the coral reef might be the exotic boulders, which means that there must be a strong force that transported the coral reef to Yujing. Next, we headed downstream along the Zhenwen River and arrived at Danei, which is the northeast of Yujing. After the investigation, we drew a geologic column of the outcrop in Danei. The geological column there is different from Yujing. The strata exposed to the air are mainly shells and sandstones that form alternately, with strong differential erosions present. There are sandstone strata with shell layers embedded or the opposite. In the strata, we also found some fossils such as scallops, trace fossils, and snails. Also, in the sandstone layer, we found some cross-bedding, which shows that this place was affected by waves. By using the phasing of trace fossils and the cross-bedding, we determined that the age of the rocks decreases as we travel west. All of the pieces of evidence we collected here suggested that Danei was once under the sea, and the environment slowly shifted between offshore and shore face. So, both shell and sandstone are seen.
So, in summary, Danei, on the map of the Tseng River, is to the northeast of Yijing, and the sedimentary facies shows that sea level was lower in Danei when the rocks formed. With this finding and the aid of geologic map, we can infer that when these layers were forming in the Pleistocene epoch, the southwest part of Taiwan was undergoing an orogenic movement, which means the sea level was decreasing. And the tectonic movement started from the north, so we can see that although the deposit time was the same, the strata in the north have a greater radius of particles than that of the south, which also shows why the areas around Gunshuiping mud volcano further south are mainly mudstone layers. Also, the marine and ecologically rich environment is ideal for gas to form. After organisms die, their body deposit down to the seafloor or are carried by waves of storms to deeper places and are decomposed by bacteria, producing methane or other types of organic gases. These gases will then be quickly buried in the very fine sediments, eventually becoming an impermeable layer of mudstone or shell, which is rich in natural gas. Another important finding in Danei is that we can see the strata are not lying horizontally. In fact, they are almost perpendicular to the horizontal plane. This tells us that an enormous tectonic movement might have taken place during the Pleistocene, as the strata were forming. According to our observation, the strata in the west are younger. We can therefore infer that there should be an syncline in the west of the outcrop, or an anticline in the east. Take a look at the geologic map. We can see that the yarn direction points toward the west, even by a greater aspect. However, the elevation of ground increases as the strata get older. This phenomenon does not occur usually, and is mostly seen in regions where stratiform systems are well developed, such as a convergent plate boundary, which Taiwan is a classic example of. With stratiform systems put into consideration, a monocline which appears as a half of an anticline is most likely to be the case. This inference indicates that there must be a strong east to west compressing stress acting on the lithosphere to create such a great deformation. All the way from Danei to Gunshuiping, we can see the same age distribution of rocks, expressing that although the ground of Gunshuiping is covered with alluvium, there might also be stratiform systems developing beneath the young strata. This will create ideal channels for groundwater and gas to travel through. The gas enriched in the underlying mudstone layers can migrate upwards and accumulate in the porous conglomerates and sandstones. Groundwater is preserved in the upper level, can also flow downwards and mix with mudstone to create slurry. With the existence of channels, the ingredient of a volcano would be much easier to form and accumulate in the near surface, and break free to the ground when the pressure of liquid and gas is high enough, similar to how dipropagation and diapirism work in magmatic activities. The low viscosity and low density properties of the slurry which are observed in Gunshuiping also creates advantages for it to rise.
After 3 days of standing in the sun and rain and countless hours of work, we finally came to the conclusion. The Gunshuiping mud volcano isn't a fossil bomb. Simply putting fossils into nature's hot pot wouldn't produce an explosion. The relationship between fossils and mud volcanoes is that they both require a rapid burial of ancient organisms once they die. Fossils come directly from the organisms, and mud volcanoes require natural gas, which is a type of fossil fuel, to form. What is it then that is responsible for the mud volcanoes in southwestern Taiwan? The first culprit, or first group of culprits, is organisms. This group consists mostly of various species of marine organisms, plus a type of microorganism called methanogens. Methanogens produce methane when they decompose dead organisms, and when enough of the gas is accumulated underground, the high pressure it creates helps form a mud volcano. The second culprit is sedimentation. Sedimentation creates an environment suitable for the formation and storage of natural gas in groundwater, and the sedimentation of mud makes the area perfect for creating slurry. The third culprit is orogenic movements. These movements move material around, and they happen to put everything that makes a mud volcano under Gunshuiping. The final culprit is tectonic stress, which caused fractures on Earth's surface. Once these cracks were formed, mud volcanoes could erupt. I hope you've all enjoyed listening to the story regarding the Gunshuiping mud volcano. It was a particularly challenging case because there were so many things to consider, but it was fun learning about it. It is a conspiracy involving the geosphere, the biosphere, the hydrosphere, and the atmosphere. Thank you for listening.